Okay, so before we actually start on the A star implementation, I actually figured out that I had a small bug in uh, this function in the priority queue implementation. So basically, when we pull an item, yeah, I mean I relied too much on Copilot to autocomplete my code and didn't check this if statement, but we actually don't need the if, and we need to do the index equals swap at the beginning. Otherwise, I mean, let's look at the problem. So if the index is different than swap, we would set index to swap and then the while loop would break. So uh, that's not good. So we do first thing index equals swap, and after that we like this doesn't need the if check because it's fine. So if we redo everything and we run the example for what no it's in build queue, we get the same results, right? So it's still good. So let me just uh, do like a fix, and I'll just do a quick commit just to not forget about it. And I think now I'm just gonna implement a star in the ds.h repo. And then when we actually use WASM and stuff like that, I'm gonna move it out from here into its own repo with WASM. So let's so basically let's start with the classic int main, return 0 and close this. And now if we do make again, it should also compile a star. Yeah, perfect. So not gonna lie, I don't remember the algorithm uh, perfectly, but yeah, I know that we need this open set, which will be the list of nodes that we want to expand. And for this one, we need the priority queue because we want the nodes in here to be sorted by the uh, I think it was, I don't remember the names in from Wikipedia, but I think it was like F score. Uh, yeah, probably. Wait, it should say somewhere. Anyway, uh, we'll see when it comes about it. But it's basically a priority queue or a min heap, and we always want to get the minimum node from here and expand it. That's why when you look at visualizations of A star, you see like the the path being like in the direction of the goal, right? It moves in that direction because it always chooses the minimum node from the open set. Then we have the parents. So this is the just to reconstruct the path. So for each node we keep from which node it came. Then we have the G-score, which is the cost from the start up to this node. It's basically like the real score, let's call it. Okay, F-score is, I think, okay, it's the G-score plus the heuristic. So it's like our guess for the uh, cost from the current node to the end, right? Or I mean from the start, right? Because it's G-score. Well, yeah, because h is the guess, like the heuristic. So f score is actually the cost, the total cost. But it's like the cost of going through that node or point or whatever. Then yeah, we have to iterate the open set, always get the best, oh yeah, f score. Always get the best possible node with the lowest f score. If we get to the end, we stop, and it is what it is. Otherwise, I mean, we already removed the node, so it doesn't matter. Then we go through all the neighbors. We compute the g-score. It's basically the g-score of the parent plus the distance between the parent and its neighbor, right? And yeah, basically, if this score is better than the score that the parent already had, like the neighbor already had, then we actually switch its parent, let's say. So uh, instead of came from being whatever it is currently, we switch it to current, and then we update its g-score and f-score. And then I see that we add it to OpenSet. So I mean, it's I think it's pretty basic. I think we can do it. We have the data structure for this, and the g-score and f-score, they should be like hash maps, but and like the word that we're gonna implement a star for is gonna be like a matrix, like a 2D array. So the hash map could be like a simple array, but we use um, the indices as the hash, like convert the 2D index into a 1D index, basically, into G-score and F-score for that. And yeah, so we have the data structure for all of them, and yeah, everything should be nice and probably easy to do. And yeah, the distance will be 1 because it's like the Manhattan distance. Well, yeah, and also the heuristic will be Manhattan distance, right? I mean, we can experiment with different implementations, but that should be it. So, I mean, we can start directly with A star. We don't need anything else. Should it return? I mean, it should return the indices, right? But I mean, let's do just an int for the start. So it's gonna be A star. It should get the start, the goal, and I think that's probably it. Oh, I think it should also get the map because we might want to have obstacles on the map. Yeah, why not? We can have a map with obstacles just to try to go around them, see a better path. So let's actually make a structure. Let's call it structure world. So it's gonna be a width, a height, and unsigned char. Man, I never get the unsigned words right. Anyway, so this is the thing. Let's have int world init. Here we can say ds log error. So yeah, and instead of using malloc, well, no, yeah, I mean, you see like the issues with malloc and stuff with wasm, but I mean, we already saw a bit because we can't use stdlib and stdio, right? Like we need to implement this ourselves, but for now we don't care because it's just the C implementation. We'll care about it when, like, when the problem arises. And let's do the free, and let's have like a really simple function of doing int word flip. Like I'm thinking of having like I mean set would maybe be better, and just to set some values on the map to make how do you call it, like obstacles. Yeah, obstacles. Anyway, we could also have like read from std. So let's do world from, I mean world from file. So yeah, I'm no longer gonna trust ChatGPT with this. So oh my god, I tabbed into it. So we get the file pointer, which is gonna be null. Okay, if the file name is null, then file will be stdin. We do the same thing as we did some time ago, and yeah, basically now we would have to read like the entire input, right? So let's see what I mean, reading the width and height, that's some weak stuff, right? Like we want to read until the end of file. So while, but no, we should have like a char line, and while we basically get a line, so while f gets, and we put here the line, okay. Let's have a define line max size of char. Wait, fgets doesn't return. Oh no, it's just okay. So we also need string okay, we need string for this thing. And here let's say we have if yeah, well, I mean, do the thing width equals length. Sure, fair enough. Do some stuff. Height plus plus. But we should also keep char pointer lines. Should also keep, yeah, probably should also keep the line. So let's have a structure. So this is gonna be char pointer items like this. We need a count. Wow, why? And capacity. Right, to use our DA append. So struct. Can we do lines? Yeah, it look fine. So this the append lines. Yeah, I think we need to str dupe. What? Well, since we need to allocate it anyways, let's allocate. Yeah, let's allocate it here. Line. No. Yeah, we can do that. It's easier like this. So let's have here char pointer line copy, and then we pass in the line copy. Which should it anyway, like yeah, whatever is gonna be pointer. Okay, perfect. So now we have all the lines, so we can actually build the world, right? So let's see. Struct world w, set it to 0. We init the thing. Yeah. Wait, we already have w. What? Oh, we already have. Well, yeah. So we don't need. So we just have to init it like this. Okay. And then we just have to go through all the lines and stuff, and if we have, let's say, an O is gonna be now a dot. Usually you put dots for empty spaces. We set 0, and for hashes we set 1. Okay, and whatever. So we have to free all the lines and return 0. Yeah, I mean, in C, what's like the hardest problem is to read and write from files and stuff. But I mean, it's fun, I guess. So let's create world. Let's init it from file, and then let's do a free. Oh, let's also print the world. So int world print. I mean, just let Copilot do. Like for stuff like this, it's actually pretty good. It already knows how we read it, and I think that always like serialization, like printing is easier than deserialization. So like if it cannot do this, then it's pretty bad. But yeah, so let's world print, and if we make wait, we have strdup is and this is a problem. Line 70 because strdup is in string.h. Okay. Lines may be uninitialized. Oh yeah, it's right. So let's do lines in it, and it should be like just put it to 0. Well, we could say no, we cannot. Lines in it. Something's a bit wrong because it shouldn't be a pointer, so we can actually say 0 instead of having a function for it. I just want it to be initialized to something like 0. But here we need like the address, right? And here it's with a point, and same here. Like yeah, we don't need it to be pointer, so it's fine. But strdup, that's weird because strdup is in string. Well, you know what? Let's malloc and then whatever and then strcopy because like why is it? Oh, we need world.txt. So I said like points. Let's do something like this. Ah, no. Let's put a hash here so it can come like this. And maybe let's make it, I don't know, go from somewhere to somewhere, I don't know where. I mean, it looks like a decent map for a test. Let's see. Invalid character in a map. That's pretty strange. Does it need another new line or some stupid thing? Oh, I think let's put like, see, like it makes sense here to print the character code, because like, let's be real, if it's a character below like the readable characters, how do you show it? So funny that new line doesn't work. Invalid character in map 0? Really? What? Wait. Let's see the width and height first. Maybe no. Printf. Okay, make and build a star. Width 8. Am I tripping? 1, 2, 3, 4, 5, 6, 7. I mean, see, like this is why I don't like Copilot. Like, why does it do stuff like this? Right? It computes the length, then it puts a backslash 0. It overrides the new line, but then when it computes the length, it does some stupid shit like that. So pretty weird. Like length becomes 1 less, basically. That's what I'm trying to say here. Anyway, so it gets it right now. Perfect. That's good. So now that we have the world, right? We have basically this unsigned character pointer map. So we have the array, we have the width, the height. Let's do int world get, just to not think about it. Here, actually, let's do something like unsigned char pointer value, and yeah, we are gonna return this like a 1, and here we are gonna say value and then return a 0, just because I think it's better to have return code, was it an error, was it not, and whatever pointer to value. Okay, so let's do int Manhattan. Wow, I mean, sometimes it impresses me how quickly it figures out what I want it to do, but sometimes it's really dumb. But yeah, basically I need Manhattan distance, just the distance between 2 points, 2 coordinates. Okay, let's do something even cooler. Int man world Manhattan distance. So we are gonna get a world index 1 and int idx 2. Okay, now I'm just thinking out loud. So yeah, I mean I'm not sure. Let's just go with it. See what happens. Okay, back to the algorithm. So now we have the heuristic. We need the start and the goal. So yeah, struct world pointer w. We need like the width, height, and the map. Then we need start x, start y, and x and y. Right? We need this good stuff. Probably we'll have like a pointer to the points that make up the path, but first, just like this. Like maybe this will be a structure, or maybe we can make some smart shit like using an unsigned long for storing two ints. Some crazy stuff like that. Anyway, so yeah, basically we have to create a priority queue now. So did we include it? Yeah, we included it. So struct ds priority queue. We need a pq. This will be open set, right? Yeah, we can. Well, I forgot that I did it yesterday. Let's see an example. So we create a structure, then we have to init, right? We have to use a open set, then we need a structure for our see, maybe we can use let's say struct position node. It should be x, y, and I think it should have just the f on it because that's like its priority. Just the f. Okay, position node. And maybe do we already convert x and y into one index, or do we keep it as int as two ints? It doesn't really matter. Yeah, doesn't right? Yeah. anyway, so I don't think it matters. So yeah, let's do int simple node, but here we want mean. So it does the, well, I don't understand why it's not just doing something like this, but here we should put b and a because we want minimum. Like if a is larger than b, it would return positive, but if a is larger than b, now it returns negative, so b should come first. Okay, so we have the open set now initialized. Okay, we create the start node and we insert, I think it's called, yeah, we insert the start node. Okay, then came from we don't do this right now. We need the G-score. So basically, let's create like int num nodes. It's gonna be width times height. Now we initialize G-score, and for yeah, actually, I mean, I would say, is there like C maximum int define? We have like int max, right? Because it's just easier. Oh, nice. We also have unsigned int max. So we create the G-score, and as I said, the index into the G-score is gonna be, you know, like this kind of index, y times width plus x, just because in C it's hard to do hash maps. So for now we just stick to the easy thing. Yeah, like we can do, let's create a structure, struct position x and y, and here we can use struct position p, and in here we can say struct position start and end, and here we can say start. So now we can maybe do int position hash. Like the only problem is we need struct world C, but whatever. Okay, so now we need to set the start to 0, like the score from start to start at the G-score, the distance is 0. You get the idea. Now we create the int pointer f score, which is the same as G. Unless here we do position hash and we compute the Manhattan distance. Even for Manhattan distance, let's see. we can do struct position 1 and position 2, position y. Okay, it's I think it's gonna be easier if we use structures like this. Okay, and now we have to actually do the while loop. Yes. So everything's looking decent. So we also need the struct position. Like we need the neighbors. Well, let's have something like struct neighbors is gonna be some positions. I mean, it feels stupid to do it like this because it's just 4. Can't we just have a function that returns 4? Struct position. Okay, fair enough. So let's do it like this. I don't care. So neighbors get. So we need struct world and the position. And we also need a pointer to neighbors. Okay, fair enough. Let's also have neighbors init. Just make it 0. Okay, perfect. And here we need to neighbors init. Well, the point is we need to just do it, you know. Oh, but it's easier. But yeah, it might be easier to just have the filters done here. So let's do it so if px is greater than 0, don't we have the, yeah, whatever, we can just do that. Okay, we can also do that and that. Yeah, anyway. So now we have the neighbors, right? And we also filtered them to be empty space and inside the map, not outside. So that's decent. while open set. Well, there should be open set is equal to damn. Okay, so while that's false, okay. What do we have to do? We have to get the current node. So position node, yeah, current node. We have to do priority queue pull, and with pull we also remove it, so we don't have to do pick. We just remove it. So here we pass in open set, and here we pass in the so this one's the pointer to a pointer. So let's define this as a pointer, set it to null, and here let's say void pointer. Okay, so we dereference it and then do void pointer pointer. And this way I remember we need to free it, right? At the end, because it was allocated. So we have to do free current node. Anyway. If we get to the goal, we just stop. So let's go to our position stuff and do int position equals if position equals for this thing I mean, sure, I would just probably break or something. So let's have maybe like result like we found stuff. Like maybe we would have to free it here. Right, but doesn't matter. And here return result. So we have to free those and open set just in case. Okay, so next up we need to get the neighbors. So let's neighbors n, and let's get the neighbors of this is what's strange, because we can assume that the neighbors are in it. We get the neighbors, and then for int I equals 0, I is less than n.count I plus plus. Here we need to do this kind of stuff, right? So we need int I mean, obviously that's exactly the line that I did like this, selected. So if this score, the G score, is less than the G score, I mean, what's like one tip when using Copilot is to autocomplete and then delete between curly braces. It does exactly what you want to do. Sometimes I would like to just complete one line because it's obvious what you have to do. But yeah, it is what it is. So we are on this line. We check if this score is somehow better than what we already have. And if it's better, we just have to, we don't do this yet, we just have to set basically I was just thinking that we do this computation every time. So what about getting this out once? We put it like int current index and this one should be here int neighbor index. That's bad. Wait, what? Okay, so it looks nicer. So as I said, we set the G score to the new score. We set the F score to basically use the new score plus the Manhattan distance, which like it was using before. I guess from F score you have to subtract the difference between these two. Like you make it a bit smaller. It becomes like a better path overall, right? And then we have to put it in the queue, but only if it's not there. Only if it's not in the queue. Let's see. Because the problem is that the priority queue doesn't really know how to. Oh, I'm so dumb. I was like, the priority queue doesn't know how to compare, but I mean it actually does. So let's do. Wait, I'm stupid. It doesn't know how to compare. Yeah, maybe this could be like a small issue. Like, how do we check if an item is in the queue? Like, easily. we can use memcompare, like memcmp, the function memcmp. This is from string. So since it's from string, I'm not sure, is it string is stdlib, right? So if we memcmp, yeah, it's standard lib, so we would need to also implement this in Wasm. I'm just thinking for the future, right? Because we already have to implement malloc, realloc, free, and exit to make it work. Oof. That's like one thing would be to add a function for like item EQ, for example. But that's like an extra argument. It looks weird. But I mean, by default, it can be null, let's say. Well, we could also just access the items inside of, I think. So like, let's say int found equals 0, int j. I was almost gonna, so here we can actually say openset.items j, and we just take the item. And we have to check if the issue with having an, well, yeah, it wouldn't be an issue because we would just use position equals for the comparison check, like if items are equal. But I guess it works like this. I don't really like to access like the underlying items of a structure, but it is what it is. So if we find it, then we have to insert it in the priority queue. And then yeah, we just free the current node. We also have to free the neighbor structure. Wait. Well, not really. With neighbor node, where does it come from? Yeah, I have no idea how we can do this in like a nicer way. Because items is allocated, then we insert it into this priority queue, and I'm thinking that when we feed it or something, yeah, whatever. Let's not think about that yet. So let's just call to A star and see what happens. The end is at width height. Yeah. Let's say here there was like a stupid little error. Okay, let's try to make and run. Obviously we get a segmentation fault, expected to be honest. Let's see here, let's print some stuff. Current node 0, 0. That's perfect. Let's see if we get here, for example. We get there. So let's current and neighbor. Let's see. 1 and 7. I mean, makes sense, right? It's 1 and 7. Yeah. Perfectly correct. Now I guess that the score should be fine, so it should come in this thing. Let's see. Let's see its score. F score is 9 for both of them. That's interesting. For both of them. So it actually comes here. It actually does the for loop. It actually does the for loop. Open set. Let's see the open set. Let's see the G score. Like, let's print everything, right? Let's use our GDB compiler basically. So the current node was 0, 0. The open set is basically like this. What? I did something dumb, I guess. Oh, yeah, so yeah, that's why we need to free it anyway. Okay, so the idea is, right, like, since this is a value, it will get overwritten and it will overwrite also in here. So we actually need to okay, let's look into the PQ example. Yeah. yeah, like it's allocated. So we might need to allocate it. Wait, how does it even make sense? Wait, let me check. So because I think this leaks somewhere, no? Like how doesn't it leak memory? Because here we initialize all the nodes. Oh, it frees periodic queue free. Oh, it's because we free the item here. Yeah, I'm stupid. Okay, yeah. So, I mean, yeah, whatever. Let's try to let's malloc. Let's set. Wait, this is. Oh, yeah. Let's do it like this because we already have n for some reason. N is the neighbors. Okay, and here we can insert a void pointer item. Okay, so now open set is looking fine. Okay, let's not free anything first. And it got the path, so now it works. But the current node is 6.2. That's strange. Right, it looks a bit strange. Found is 1. Oh, here I'm printing the result. That's not good. Oh, yeah, like it's good, but well, what I'm not doing right is that I should actually print stuff like that here maybe. But it looks like it does something. But it gets to, oh yeah, it's 6.3, right? The because the map is 7 by what? By 4. Yeah, so it's good actually. It gets to the end. So since we managed to get the end, let's implement the pathing thing, like this small function, reconstruct path, let's call it. So reconstruct path, it should get the came from. Oh my god. So came from should be the same as gscore basically. So let's have int pointer came from. Everything is -1, and I think that's how you do it. And now when we update, it's only when we update, right? Came from, we do this. Yeah. So when we get a better score, came from, like parent, maybe whatever, let's call it like on Wikipedia, just to, but this is like the parent of this node is this node. So let's actually give it a struct world w came from, then it should get struct position current, and let's say, let's create a new structure for path that should be like this, and here we should get struct path pointer, and it should be called p. So da append, we need to append the current into the path, but again it's like, wait, the append puts here like the item itself. Yeah, I think might be fine. Okay, anyway, so then we have to say we get the current index, and then while came from is not -1, we have to update the current index and see, like here again it's the same issue with like we had here. But let's see, because maybe since the append takes an item, maybe we can actually trick it into anyway. So basically this should get the struct path, and here we should say reconstruct path. Now we should have struct path p, and let's pass the path. No path found. And here let's show the path, right? Also, we still print some dubious. So it goes to 0, 0, then 1, 0, 2, 0, 2, 1, 3, 1, 3, 2, goes up until the end, and then on the bottom. Yeah, I mean, to me it looks like it's actually working. Pathfinding, right? Like it actually worked. Well, that's the world, showing the world, and this is the path from the start to the end. Really nice. Let's try to go here actually. So it's 0 for height. It's 0 for height. It should come until 5, 5, 2, and then 5, 1, 5, 0, 6, 0. Yeah, it works. It complains about something here on line 261. Wow, we have almost like 300 lines. I didn't even realize that. Oh, yeah, we don't care about unsigned, whatever. We are 2 gigachats to, like, we know our signs, we don't need to specify unsigned. Come on. Okay, yeah. So, but this annoys me. Signedness. Bruh, chill, dude. Chill. Anyway, yeah, like it gets the path, and that's all we wanted. Well, something else that I would like, but I don't think it's. Yeah, this is sad. So, first things first. We have to free came from G-score and F-score. These are the easy ones. Free came from G-score and F-score. Like this was the let's do. I was like, what the hell, it didn't work? Oh my god, it decreased by only 3. I I always like that when it happens. So let's also delete the open set. Indirectly lost. We no longer have indirectly lost. That's nice. So this is what I would do there. Let's see now. I would also have to delete the neighbors, right? So here, free and items. We don't have a function for it. almost doubled. Almost doubled it. I think what's something else we alloc. So we alloc here, here we free this. When we pull, the only thing we can pull is items from a queue. That's yeah, we don't have to free it. It's fine, I was just overreacting there. So the neighbor, I have no idea what's I would literally just free the current node here because we alloc the node, right? Oh, you know what's the problem with that? Here, start node is not allocated. So let's switcheroo that. Start. Wait, what? I mean, it doesn't matter what we put in the, like, you just say start. Well, yeah, actually, we could be like, oh, let's put it like this because it's the first node anyway. So when we are gonna pull, we are gonna take it. So that was the issue with the Sigabort or whatever the error was, because free doesn't work on stack, obviously. It works only on the heap. So hopefully this should leave us with like 1. Definitely lost. So here when we break, yeah, we need to free the current node. And then before we free the queue, we have to well, while is not empty, we have to pull from the queue and then free it. So damn it, 2 more blocks. But these are huge, they're humongous. So what can be in these blocks? Right, they are pretty large. Okay, let's see what happens if we don't call to A star. Do we still get those huge allocations? Yeah, we still get 1 huge allocation. So it's something from here. We do some open. We get some trash lines. Here we copy the line, so we allocate. Ooh, we allocate some stuff, and then we DA append it to lines. we then do this kind of stuff for world, and then we free all the lines. Well, we should also free this thing, right? No, we should not. But why not? Oh, it has a problem with strcopy. Okay, yeah, so we should free the lines, right? But strcopy, as usual, it's pretty stupid because we actually have to malloc one more. Like keep like this should be. It happened to me so many times. When you copy like when you work with char pointers, you have to always malloc one extra because you have the um, you know, this extra byte at the end. I don't think I have to do this, but yeah, you have to keep in mind that you have to always alloc one extra to get rid of this, like this. Yeah, I mean at some point you'll get used to it and figure that out, but that's what you actually have to do. Put one extra there to make sure you don't forget about the byte 0. Anyway, let's see now. Not sure where the extra thing comes from. So like we free this thing because it's like the same size as the world. We also free this one, this one. Yeah, literally have no idea what's left to free. Let's do one dubious thing and let's not insert anything. Let's see what happens. So maybe this is the thing. Maybe we found it. Maybe we actually found it. It's something that's 12 bytes. Let's search for it and see where this mother sucker is. Looks like start node, doesn't it? Well, yeah, obviously it's start node. So maybe it wasn't this thing. And let's not insert in the priority queue here. Let's see what happens. We lose 2 blocks. Yeah, well, but I mean, what's important is that we actually get the path from start to end. So I guess that's that. But maybe someone saw it and will put it in the comment where the last free was, and I can maybe try to figure it out, but it's not important, you know. It's just a bit of memory leak. No one will die from that memory leak, so it's fine. We get a path. That's important. That's what's important, right? And the next time we can try to show it in a UI in the browser and allow you to click on tiles, so you flip them around, put like walls and stuff, and then show the path from the start point to the end point. So yeah, basically that's it.